This is good, because I want to watch it over and
Yeah.
over
And over.
and over and over and over. I'm being as short as I can.
Sit down. Sit down.
What I'm starting is just the construction of a cylinder mechanically. The main thing is I've got to have, if I'm doing a cylinder, I can have it any height I want. This is really getting distorted. It's going to be a very short cylinder. But the critical thing is I have to have a square, right, to fit the circle into a square. Okay, so this side, how far over do I come? This is just an approximation. I've never shown you also the way to be a little more accurate. You're doing stage sets for architectural rendering. All I'm concerned right now is just building a box with at least the top and bottom being square, or appearing to be a square. The problem with this kind of perspective, you always get distortion. So I'm going to draw this in a little heavier so we can see the top, because that's all I'm going to really be. No, I guess I have to do the whole thing. Okay, so this should represent a square, and I'm not going to go through and find all the midpoints mechanically, but let's just say they're here. So if this is my cylinder, or ellipse on the cylinder, now, we're going to project a shade, a shadow, a cast shadow, and the light source will just determine arbitrarily it's up here, and we come down to an arbitrary point. We want it behind this. So this is the top, this is the base. How do I know this is behind this and not out in front?
Because the base will be below.
Yeah, if it were in front, you see, it would be a point down here. So if you understand the perspective as we go further up, the closer we get to the eye level. So this is behind that. We also know that we have to draw from the top point, as we did with all forms, to either the corners here, which you could go laboriously and create a projection of this box, and then in that box create, as we did here, an ellipse. But it's a lot easier to just arbitrarily say, okay, if I have a line from that light source, and it's got to be tangent, right, with this. So if I come down like this, it's not tangent with that, but this is going to be tangent, right? That's tangent. This touching this part of the ellipse. You understand what I'm saying?
Mm-hmm.
Mm-hmm.
Yep.
And what do I do here? The same.
The others.
Okay, so here's my light, the top of it, the base of the light, and it's going through this point here and this point. If I want to find the bottom one, I could draw, again, a tangent line there, or if I drop down straight from that tangent point, right there, that's exactly what I should expect from this base point here through that. okay? And from this base point here, of course, this ellipse is going to go around like so. So right there, right? Here's the ellipse, dropping straight down where it's connecting there. And that would be and so we can see that the shadow is going to get wider, as it should, as it moves further away from the cylinder. I'm just going to draw this in so you can see the cylinder a little bit better.
So, why would you not go down here as opposed to up here?
That was my
That's my
question.
question
Look,
too.
down where?
Why wouldn't you go right from this point as opposed to up
No, it
here?
has to be at the tangent point, the tangent point.
But,
And it's around the other
It's
side of the
around the
cylinder.
other side.
So it's not forward
oh,
of it,
oh,
it's
oh,
behind
okay,
it.
okay.
See, this corresponds to this. You come down until you hit this. Because that, if it's tangent here, it's got to be tangent there.
Okay.
Tangent here, okay, and tangent here.
So, if you had made the crossing that you did, this would be the center bottom, this would be the center top. Okay.
Okay, now, as I say, I can project this box out and do all this stuff out here, but something much simpler. If I just arbitrarily say, there's 1, there's 2, 3, 4, 5, and if I draw from here through those points, each one of these points here, and I could have an infinite number depending on how accurate I want to be. I'm just going through these arbitrary points because that's exactly what the infinite number of light rays are doing. Right, all these. And for every one of these, if I drop straight down, if I drop straight down, if I drop straight down and straight down, and I go through, for example, just this one here, I'm going to make this a little more accurate. Now I've got the top, which already is being intersected, right? Through the top. I come down, and it has to be intersected by the baseline. And that's where that point is. Here it is here, here it is here. Do you see how I can do that for each one of these?
So that's kind of what I was doing here.
That's what you were doing. You just had to go a little bit further here because you have a little bit pointed there.
Right.
But the point that I'm trying to make is that you will plot out all of these points and then just connect the dots.
Can you plot a few more?
Okay, you do it.
Just for asking a question.
I was trying to
Well,
understand.
we've already got the tops. We have we need the corresponding base of this one here.
Of this one
Yeah.
here.
Okay,
There's
there
the
it is.
base, and then
Right there.
Okay, and where does it cross the other line?
Right here.
Right there. Okay, put it down. Okay. The next one?
Next one
Yeah.
would be right here.
If it doesn't work well, it's because it's got Rita written on it. No. Good.
Right there.
Now-
Wait, that's weird.
right.
Mhm.
But what about these?
So right there is, that one's already turned, put another dot there.
Where?
right
Right
here.
here?
At that intersection.
Yeah. Okay, now start to connect those dots, okay? And you can carry that all the way around.
And with the sphere, it would be the same thing, you do the lines that are, I guess
Yeah,
you'd say
let me have a
tangent
softer
to the,
pencil.